All right, in this problem, we have a guy pushing a boat, and all he is trying to do is get it moving. The question asks, how much force would it take for him to push to get the boat moving? So this implies that the boat is not moving initially. It is static. It is stuck. So he needs to overcome static friction force. He needs to push with enough force to overcome static friction. He's going to be pushing this direction with an applied force. Static friction is going to be resisting in this direction with some resistive force. Okay, so it's a tug of war, or like a blocking, two linemen pushing each other, okay? Who's going to win? Well, we want the guy pushing to win, so we need to figure out how much the force of static friction can apply. And once we know how much the force of static friction can apply, we'll know how hard the guy needs to push with. So let's first find the maximum amount of static friction force that the guy can, or that the boat can produce. So the first thing you do is you write out your knowns. We know the mass of the boat is equal to 900 kilograms. Okay, we know the coefficient of static friction is equal to 0.56. We know the coefficient of kinetic friction, which we don't need, is 0.45. So, the equation of static friction is equal to the normal force, not the net force, times the coefficient of static friction. Remember, the normal force is really, it's the weight. It's the weight of the boat times the coefficient of static friction. So, solving for the normal force, because this boat is not accelerating vertically, the normal force is simply mg times coefficient of static friction. Thus, the mass of the boat is 900 kilograms times the acceleration of gravity is 9.81 meters per second squared times the coefficient of friction is 0.56. And when you multiply all this out, we get out, sorry, this should be kilograms. We get out 900 times 9.81 times 0.56. We get out 4,944 newtons. So that is the force, the maximum force that static friction can push with. Now in this problem, you'll need a free body diagram. He is going to be pushing with an applied force to the right. Static friction is going to be pushing or resisting with a resistive force to the left. We just calculated that the max is equal to 4,944 newtons. Okay, that's the maximum force that static friction can apply. Therefore, the applied force must be greater than 4,944 newtons. And that is your answer.